Good day, everybody. Welcome back. Today we are going to look at the reciprocal function, f of x equals k over x. Well, why is it called the reciprocal function? Remember, reciprocal means 1 over something. So this is the reciprocal of k times x. Well, it's the reciprocal of that part anyways. So a reciprocal function is a number, a constant, a real number divided by x. And all of these graphs have the same basic shape. And if you refer back to the parent function lesson that we looked at, you'll remember what the graph of 1 over x looks like. It's going through the points 1, 1, and negative 1, negative 1. And it has two asymptotes. It has a vertical asymptote, x equals 0, and a horizontal asymptote of y equals 0. So what's the deal with k? What does that do? Well, if you think about the function transformations that we've studied, that is going to be a vertical stretch. So that's going to take these points and it's going to stretch them in the vertical direction. If we had 2 over x, this point that was at 1, 1 would be at 1, 2 now. It makes the graph steeper. So let's find and graph a couple of these. We need the equations of the asymptotes, we need to sketch it, and we need to state the domain and range. All right, so y equals 9 over x. Are there any translations there? Is there any addition happening? Think back to function transformations. Hopefully you're saying, no way, there's no translation. That means that our asymptotes are x equals 0 and y equals 0. So our graph starts by this asymptote, it's going to go up, but it has a scale factor of 9, so this point that was at 1, 1 is now up here at 1, 9. And negative 1, negative 9. And the domain would be the set of all x's such that x does not equal 0. And the range, the set of y's such that y is not 0. So pause the video and see if you can't graph the second one. Okay, well maybe you restarted the video and you said, wait a minute, that doesn't look anything like what we've just been talking about, Mr. S. That can't be anything related to this. Well, it is if you think about exponents. We could rewrite this as negative 3 over x plus 2. Remember, this negative exponent means go 1 over x. So now that we've talked about that, now try to graph it. All right, so I'm going to graph and do asymptotes kind of at the same time here. I'm going to ignore the plus 2 for the time being. The negative, that causes the graph to reflect across the x-axis, remember. So this branch up here is now reflected into quadrant 4. And it has a stretch factor of 3. So it was at 1, 1, it was right there. So it got stretched up 3 units and reflected. So it's now at 1, negative 3. And similarly back here, negative 1, positive 3. And if there wasn't a plus 2, I could draw my curve right now, but there's this plus 2, so these points have to move up 2 units. So now I'm at 1, 5, negative 1, 5. My asymptote that was the x-axis is now up 2 units. And this point 1, negative 3 goes up 2. It's now at 1, negative 1. And now we can draw our curve. The horizontal, or the vertical asymptote doesn't change because there was no horizontal shift in this problem. There is nothing down here being added or subtracted to the x. So my asymptotes are X equals 0, y equals 2. It's the vertical translation. These asymptotes are going to correspond to the translations that we do to the rational function, the reciprocal function, every single time. And those translate directly into the domain and range. The domain is the set of x's such that x does not equal 0. And the range, the set of y such that y does not equal 2. And there we have it. There's our two graphs. This first section is all about, can you build these simple reciprocal graphs that have the shape that we call a hyperbola. This shape that we have with the two branches there with the vertical asymptote, horizontal asymptote, these are called hyperbolas. So with that in mind, go forth into the world and do great things.